Pluto is a far-off and clandestine extra-modest planet that was as soon as a part of our close-by planetary institution. However, ongoing worrying announcements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have delivered Pluto back into the spotlight with an astonishing revelation. They cautioned that this cold globule is on a capacity collision route with Neptune. However, how could this clearly work, and what may be the results of the sort of significant event? Are we seeing a charming cosmic idiosyncrasy, or is there something more to this coming near-infinite coincidence? Be a part of us as we observe the likely results of a Pluto-Neptune impact. Pluto, a former planet that was minimized to a dwarf planet, remains a topic of interest, and have a look at inside the cosmic network. As indicated by current forecasts via leading professionals, Pluto's orbit is dangerously near Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm approximately a likely dangerous collision between these planets, which could pose an incredible risk to Earth. However, how is such an occasion even possible? Pluto's adventure across the solar is not like that of another planet in our Sun system. It requires a spectacular 248 years to complete an unmarried orbit. Considering that its discovery in 1930, it hasn't even finished one full revolution. But the interest would not forestall there. Pluto's orbit is marked by means of its noticeably elliptical shape, wandering significantly from the nearly round orbits of the essential planets. What makes Pluto's orbit even more awesome is its inclination, decided at 17 degrees to the ecliptic plane. The manner Pluto follows its direction is a lot greater severe as compared to different planets. This inclination and eccentricity add layers of complexity to its orbital layout. One of the maximum exciting elements of Pluto's orbit is its crossing point with Neptune's. For around 20 years in every orbit, Pluto truly moves towards the solar than Neptune, trying out what we may want to assume from their positions within the solar machine. This prompts the regular question: why hasn't Pluto collided with Neptune? The answer lies inside the gravitational impacts of other planets. The look at of Pluto's orbit started out shortly after its discovery. First of all, astronomers attempted to parent out its specific path. Not like other planets whose orbits lie pretty close to the ecliptic plane, Pluto's orbit stands proud with its steep inclination and elliptical shape. The mystery grew with the conclusion that Pluto's orbit does in fact cross Neptune's. The steadiness of Pluto's orbit amid those intricacies is proof of the complexities of celestial mechanics. The three-frame problem in space entails determining how three items in space, like Pluto, Neptune, and the solar, flow and affect every different with their gravity. It's like trying to are expecting in which they may go primarily based on in which they commenced and the way they pull on each other. In Pluto's case, this problem indicates how its orbit, Neptune's orbit, and the Sun's gravity all paintings together in a complicated way. The phrases asynchronous libration, orbital precession, and the VSK oscillation are critical for this puzzle. In step with astrophysicists, what keeps all planets of their orbits is asynchronous libration with admire to Pluto and Neptune. This time period means that whenever Pluto crosses Neptune's orbit, it's far positioned at least 90 degrees far away from Neptune. This spatial separation is crucial in keeping their orbits from converging. Orbital precession, then again, refers to the vertical movement of a body in its orbit. For Pluto, which means while it comes closest to Neptune or some other massive planet, it's miles located a long way above their orbital aircraft, providing an additional layer of safety from capacity effects. Some other vital thing in this situation is the VSK oscillation, named after three researchers, Zell, Kai, and others who studied how objects move in area. It involves the way three space items like Pluto, Neptune, and the Sun pull on every different with their gravity. This pulling impacts how they circulate. In Pluto's case, the VSK oscillation helps us apprehend why its orbit near the Sun is so unusual. Notwithstanding Pluto's direction seeming erratic, this oscillation allows keep it shifting easily over long intervals. The VSK oscillation suggests that despite the fact that matters in space appear chaotic and unpredictable, some styles and policies keep the whole thing so as. Those factors help preserve Pluto's orbit solid, making sure that it would not collide with Neptune or stray off course. This three-frame problem is essential to information how these orbits trade because of the manner space gadgets pull on each other. Analyzing this allows us study extra approximately Pluto, our close-by sun system, and even remote worlds and their stars. Numerical simulations in the past 1980s discovered that no matter these solid properties, Pluto's orbit is in reality risky, with minor deviations in initial situations mean to huge variations over hundreds of years. However, these unusual houses of Pluto's orbit have been observed to hold stability over fairly long-term scales, correctly keeping the disruption under control. Later programmatic studies have helped us apprehend how the giant planets like Neptune, Jupiter, and Saturn have an effect on Pluto's orbit across the solar. Neptune has a unique relationship with Pluto, where for every orbits Pluto completes around the solar, Neptune makes 3. This dating allows keep Pluto's orbit strong. However, Neptune isn't the only one at paintings. Jupiter's gravity additionally performs a large position in stabilizing Pluto's orbit. Saturn also contributes. Those research display that Jupiter's big gravity is robust enough to make certain that Pluto stays on a constant course for a long term, even thousands and thousands of years. So, it is as if Neptune, Jupiter, and Saturn are all working collectively to make certain Pluto maintains to move accurately via area without strolling into hassle. These phenomena are vital for maintaining order and stability in area. Without those mechanisms, the Sun gadget as we realize it could be a miles extra turbulent location. Our bodies like Pluto ought to collide with others or be ejected from their solid orbits, triggering a chain reaction with different celestial bodies. For Pluto, especially with discussions approximately it probably slamming into Neptune within the destiny, expertise its orbit is essential. This presents a clearer image of the dynamic nature of the Sun gadget. The case of Pluto indicates how even the most seemingly unstable orbits can attain a kingdom of equilibrium via the complex interplay of gravitational forces and orbital mechanics. It additionally demonstrates the importance of continuous remark and study of these phenomena to higher draw close our area in the universe. Exploring the depths of area frequently leads us to confront the strange nature of celestial bodies, and Pluto's orbit is a super representation of the unpredictability of orbital chaos. This refers back to the delicate dependence of a celestial frame's orbit on its initial situations, that is without a doubt illustrated in Pluto's case. Which means that even moderate changes in the dwarf planet's role or pace can notably modify its lengthy-term orbit. The usage of programmatic simulations has been immensely useful for researchers in identifying how Pluto moves in space. Those simulations use complicated arithmetic to model how Pluto and different area gadgets like Neptune pull on each different. By tweaking small details inside the simulations, space scientists can see how even tiny changes will have a massive impact on in which Pluto finally ends up. Within the overdue 1980s, those simulations showed something exciting approximately Pluto's orbit. Although it has factors like asynchronous libration and orbital precession to preserve it stable, its orbit can still be erratic and kooky. In case you start with only a small difference in which Pluto is or how fast it's shifting, its orbit ought to grow to be searching absolutely extraordinary after a few years. Yet, in spite of this chaos, Pluto's orbit stays strong over actually lengthy stretches of time, like billions of years. This clearly way that Pluto's journey across the solar has a sort of order to it, even though it appears turbulent before everything. Predicting celestial occasions, specifically after they involve violent orbits like Pluto's, is a big project. The inherent unpredictability of those systems weigh that lengthy-term predictions are regularly full of uncertainties. Whilst numerical fashions offer powerful gear for understanding and predicting the destiny paths of celestial bodies, in addition they spotlight the boundaries of our predictive abilities. These models rely heavily on the accuracy of preliminary conditions, and any small blunders or distortion can cause vastly different results, making unique forecasts a daunting venture. Furthermore, the turbulent nature of planetary orbits like Pluto's reminds us of the ever-changing and dynamic nature of the universe. At the same time as we have made big strides in know-how area, Pluto's case reminds us how a whole lot our know-how of the universe still remains restrained. Information the gravitational outcomes of the giant planets on Pluto's orbit gives valuable insights into the broader dynamics of the solar gadget. It indicates how the presence and role of each planet can notably have an effect on the stability and path of different bodies in the device. So why are main astrophysicists these days elevating worries about a potential collision among Pluto and Neptune, in spite of these kinds of complicated forces looking to prevent such an event from occurring? Neil deGrasse Tyson, a prominent astrophysicist and a prime discern in popularizing cosmology, offers a unique perspective at the mysteries of our sun machine, particularly the fascinating case of Pluto. Tyson, regarded for his function in renaming Pluto from a planet to a dwarf planet, gives insightful analysis at the evolving nature of celestial mechanics and the public hobby inside the not-noted realms of space. Tyson's function on Pluto's renaming is primarily based on the ever-growing understanding of our sun machine. He views the renaming now not as a diminishment but as an important adjustment to our increasing expertise of the many our bodies orbiting our sun. Tyson's approach to celestial mechanics is considered one of persistent mastering and transformation. He sees the complexities of orbits like Pluto's as a signal of ways a good deal there may be still to find out in space. The intrigue of those questions is what keeps the study of area so interesting. But, despite Tyson's optimism, his mind on Pluto's potential collision with Neptune paint an exclusive picture. His issues approximately the future of Pluto's orbit's advocate that we may also nonetheless have a whole lot to learn about its moves. The potential collision among Pluto and Neptune remains theoretical at this point, and Tyson notes that it is not predicted to take place quickly. In step with Tyson, these items are not likely to collide for as a minimum some million years. But the developing hobby in this cosmic puzzle highlights the value of analyzing celestial dynamics in more detail, shedding light at the mysteries that hold to spread in our huge universe.